Now let us see exercise 6.5. First bit, for each geometric progression, find the common ratio and then find nth term. So in that first sum, 3, 3 by 2, 3 by 4, 3 by 8 up to so on. Already given it is a GB. Now to get common ratio, simply find A2 by A1, that is 3 by 2 by 3. So we can get easily 3 by 2. So 3 by 2 by 3 means we can make it as 3 by 2 by 3 by 1. Then to get this ratio value, simply this 3 by 1 becomes reciprocal into 1 by 3. 3 by 2 into 1 by 3, as we know already this one. So here 3 gets cancelled. We get simply 1 by 2 common ratio. Simply we got common ratio 1 by 2. So here we need to get AN. So what is AN? Already we discussed it. AN. What is AN? AN is equal to A into what to the power of n minus 1. Okay. So here A is equal to simply first term 3 and R value 1 by 2. And that is simply 3 into 1 by 2 whole to the power of n minus 1. So simple. This one is A. Simple sum. Okay. And the next, let us see third one. So remaining you can do easily. Minus 1, minus 3, minus 9, minus 27 up to so on. Okay. Now here again R. Simply you can write it as A2 by A1. Then minus 3 by minus 1. Minus gets cancelled, we get 3. So common ratio we got 3. Okay. Now nth term, what is the nth term formula? An is equal to A into R to the power of n minus 1. Now substitute A value, that is minus 1. Okay, and the R value 3 to the power of minus 1. So we can write it as minus 3 to the power of n minus 1. Okay. Now let us see the second one. So here find 10th, nth terms of GB. 5, 25, 125 up to so on. So now here given GB 5, 25, 125 up to so on. Simply you can find here common ratio A2 by A1, that is 25 by 5. By cancellation we get simply 5 5s are. So common ratio we got R is equal to 5. So here they are asking 10th term. So here we can apply anyhow nth term only. Nth term formula An is equal to A into R to the power of n minus 1. Then A10, that is 10th term, is equal to A into R to the power of 10 minus 1. That is A10 is equal to A into R to the power of 9. Now substitute A is equal to 5. R is also 5. So then A10 is equal to 5 into 5 to the power of 9. So simply we can write it as 5 to the power of 1 plus 9. Since we know that in exponent laws, if a power m into a power n, then we can write it as a power n plus n. That is, if bases are equal, power should be added. Okay. By that formula we can write 5 to the power of 1 plus 9. Simply we can quote it as a 5 to the power of 10. Okay. So no need to expand it, simply leave it as it is. Now we are to get A, that is A into R to the power of n minus 1. Again here substitute A value 5 and R value also 5. So apply the same formula. 5 to the power of 1 plus n minus 1. Here plus 1 minus 1 gets cancelled. Then we get 5 power n. Okay. So like this we can check second part. And third is also similar type. Here in this bit we have two sums, I am telling second one. Okay, so here find the indicated term of each geometric progression. Okay, now here I am telling a second one. A1 is equal to minus 12, R is equal to 1 by 3. They are asking what simply A6. Okay, here directly we have the first term, that is A1 is equal to A is equal to, we have minus 12 and the common ratio 1 by 3. We have to find A6. So again we can apply AN formula, that is A into R to the power of n minus 1. Now substitute A is equal to minus 12, R is equal to 1 by 3 and n is equal to 6. Okay, now A6 is equal to first you write A6, A into R to the power of 6 minus 1, that is A into R to the power of 5. Now substitute A value minus 12 and R value 1 by 3 whole to the power of 5. So we can write it as minus 12 into 1 to the power of 5 is simply 1, 3 to the power of 5. Okay, 3 to the power of 5 means how much? We have to write 3 5 times. 3 into 3, 3 into 3, 3. Multiply 2 to 9 into 9 into 3. That is 81 into 3. So we get simply 243. Otherwise you can write for simply 81 into 3. For simple calculation, 81 into 3. So you can cancel 3 ones are 3 4s are. So to get easy cancellation. So minus 4 into 1 minus 4 by 81. Okay. So this is the third bit sums. Now let us see the most important fourth bit. For they are asking for 4 marks from this bit. So which term of the GP root 3 root 3 up to so on is 729. Very important for 4 marks here. Okay, so here in solution, so given GP root 3 root 3 up to so on. So here we have to find the which term is 729. We have somewhere 729. We have to find the number of this term, particular term. Okay, so here first of all write A1 is equal to root 3. Okay, then common ratio, immediately find common ratio. R is equal to A2 by 11. This simply we can make it as 3 by root 3. So again on rationalize root 3. So that's why we have to multiply and dividing by the root 3. As you know already the process, that is multiplying and dividing root 3 by root 3. So we can get 3 root 3 by root 3 into root 3 square. Here square root square gets cancelled. Then we get easily 3 root 3 by 3 gets cancelled. So we got our value root 3. Okay, now here let us suppose that term be some an. Okay, now an formula a into r to the power of n minus 1, that is 729. Now here a value we have root 3 and r value we have that also root 3. Okay, so now that by substituting what we get root 3 into root 3 power n minus 1 is equal to 729. Okay, so here again root 3 is the common base, so we can write it as root 3 to the power of if base are equal, power should be added. So root 3 nothing but we can have the power 1 on the exponent. So root 3 power 1 plus n minus 1. So 729. So factor is 729. So later we will do. So here plus and minus 1 gets cancelled. Root 3 power whole power n 729. So 729 we can factorize by using the prime factorization method. We can write 3 2s are 3 4s are 3 3s are 3 8s are 3 1s are again 3 2s are 21 balance 3 7s are 3 9s are 3 3s are 3 1s are. How many 3s? 1 2 3 4 5 6. So we get simply 3 power 6. Okay, now root to 3 nothing but we can write it as 3 power 1 by 2 whole to the power of n is equal to 3 power 6. Okay, now the next a power n whole power n nothing but a power m into n. So that's why by that we can write it as 3 power n by 2 is equal to simply 3 power 6. So here on both sides we have the same basis. So since as we know if x power m is equal to x power n, that implies we can write m is equal to n. So by that we can write n by 2 is equal to 6. Then on cross multiplication we get n is equal to 6 into 2. Then n is equal to 2. So the 12th term, okay, 12th term is here 729. Okay, therefore 12th term is equal to 729. Okay, so like this, one more important sum we have. Which term of the GP 1 by 3, 1 by 9, 1 by 12 up to so on is 1 by 2187. Okay, now here given GP 1 by 3, 1 by 9, 1 by 12 up to so on, we have somewhere 1 by 2187. We have to find the number of this term, okay, which term it is. Now here we have already a1, that is a value 1 by 3. So immediately find our value, that is r is equal to a2 by a1. Okay, by the same process. So here a2 value is 1 by 9, a1 is 1 by 3. So we can get simply 1 by 9 into by reciprocal of this one, we get 3 by 1. So 3 1s are 3 3s are, we get simply r value as 1 by 3. R is equal to 1 by 3. Okay, now let us say it is an is equal to 1 by 2187. Okay, so an formula a into r power n minus 1, that is simply 1 by 2187. Okay, now so substitute here a value 1 by 3, r value is also 1 by 3. So 1 by 3 into 1 by 3 to the power of n minus 1, simply we can write it as 1 by 2187. So here again base are equal, then what should be added. So you can write it as 1 by 3 to the power of 1 plus n minus 1 is equal to 1 by 2187. Again we have to make this 2187 in terms of exponent of 3's. Okay, so 1 plus 1 is cancelled. Then we get simply 1 by 3 to the power of n is equal to 1 by 2187. So again factorization, see this carefully once again I'm telling. 3 by 3 table only. 3 7s are 21. We have 8, 3 2s are 6, balance 2, and again we have 27 balance, 3 9s are, okay, and again 3 2s are 6, balance 12, 3 4s are, and again 9 balance, 3 3s are, and next 3 8s are 24, 3 1s are, and again 3 2s are 6, 21 balance, 3 7s are, 3 9s are, 3 3s are, 3 1s are. So here how many 3s? 1 2 3 4 5 6 7 3s. Then we can write it as 1 by 3 whole power n is equal to 1 by 3 power 7. So 1 can be make it as 1 power 7. So that's why 1 by 3 whole power n is equal to, we can write it as 1 by 3 to the power of 7. So on comparing on both sides, as we say, just before. Okay, that is a exponents. If the bases are same, then we can equate the exponents. Okay, already I said in the before sum. Okay, so in that way we can write n is equal to 7. Therefore the seventh term is 1 by 2187.